Hi, this is Richard C., a math tutor with Wyzant, answering another question from a student, submitted by a student. This is using the law of sines, which is something that you learn in pre-calculus. Well, it's a word problem, so whenever you see a word problem, you're generally going to want to draw a diagram. So we're going to draw our diagram now. So we have 2 points on the ground. Oops. 2 points on the ground, A and B. And these are 58 apart. And the satellite is on one of the two stations, angle of elevation at A. So here's our satellite here. And the angle of elevation for A, which is measured like this angle is the angle of elevation. This is going to be 86.7. And the angle of elevation from point B to the satellite is going to be 83.4, like that. Okay. So it's important to make sure that the satellite is to the left of A, because you see, imagine if you were standing here at A, you would have to tilt your head up farther to see the satellite. So the tilt of your head, which is this angle, would be bigger, whereas the tilt of your head from point B would be smaller. So you have to make sure that satellite is positioned correctly with respect to A and B. Okay, so now the next thing is we start filling in what we know. So if we take 180 degrees here minus 86.7, we're going to get 93.3 here for this angle. 93.3 for that angle there. And then if we subtract 180 again from these two guys, we get 3.3 up here. I always like to fill in what I know. Okay. So part A wants us to figure out how far away is the satellite from station A, which would be this distance x. So how are we going to do that? Well, we have an side angle situation over here. Sorry, we're given this side here, angle, side, angle. And when you have an angle, side, angle situation, you're going to use the law of sines. So for part A, we'll take the sine of 83.4 over x is equal to the sine of 3.3 over 58. This is the law of sines, which says the sine of an angle divided by the length of its opposite side is equal to the side of some other angle in that same triangle divided by the length of its opposite side. So that's the law of sines. If you're not familiar with law of sines, you should double back and do some work on this. You might have missed a lesson or something in school. So we're going to solve this for x. We cross multiply, so x is going to be 55 sine 83.5, 4 here, sorry, divided by the sine of 33. Now I'm going to go on my calculator. Make sure you're in degree mode. This is all in degrees. The angles are in degrees. And we just plug this in, 55 times the sine 83.4. Then divide that by the sine of 33.3. Sorry, that point didn't come out very well. 3.3. sine 3.3, and my calculator gives me 950. So hopefully I did that right. It looks right to me. 55. Is that 50? No, that's supposed to be 58. Sorry. 58. Let me do that again. 58 sine 83.4 divided by sine of 3.3. I get 1,000. So I don't get that 950. I get 1,000. Actually, 1,001. It's kind of a strange answer. So let me go back to the diagram here, and we'll put in 1,001. Erase that x, fill it in with 1,001. So that's part A. Now part B, I'm going to switch colors here just to differentiate the parts. Part B is we want to know how high the satellite is off the ground, so we're just interested in this height here. And this is a right triangle, of course. Now we have an angle here of 86.7. So this is just a simple SOHCAHTOA issue here to get H. So we're interested in the opposite, and we have the hypotenuse. So we're going to use sine, because that involves the opposite over hypotenuse. So sine of 86.7 is going to be H over 1,001. Multiply both sides by 1,001. So sine 86.7 times 1,001. And I get H is roughly 999. They don't give us any rounding instructions here, so I'm just gonna do what's convenient for me, and I'll put a 999 in there for the height. So this hypotenuse is 1,001, and this height is almost as long as the hypotenuse, but not quite as long. So we haven't violated the rules of right triangles, where we know the hypotenuse has to be bigger than either of the legs. My guess is the satellite's really, really close. Obviously, if you could, from Pythagorean theorem, you could solve from this distance. This is going to be very, very small. And the diagram's not drawn to scale. B is going to end up, if I were to draw this to scale, B would end up being like somewhere over here. But I think it's nice to have it the way it is, the diagram, because you can read everything. You need to be able to read all the numbers. But it's a fairly easy problem. So part A is law of sines, part B is just SOHCAHTOA. So that wraps things up. I hope you enjoy your travels through the world of trigonometry, and I'll talk to you again some other time. Bye-bye.